Hello, amazing science students. Tomorrow's a big day. You'll be taking your STAAR science test. And I just wanted to go over a few things that you had mentioned to me that y'all kind of wanted to review on this last day. So I'm making a video hoping that you'll replay it tonight and also maybe in the morning, just to give you that one last bit of review and information that you might need. I would also like for you to study the study guide, and if you have not finished or done the quizzes that I gave you on Google Classroom, you can do that as well. Also, the flashcards that we gave you. So you've got a lot of good information that you can study. But just for one last hooray, let's look at 8-man one last time before the test, the 8-man strategy. So what you're going to do is you're going to take your look for your atomic number, which the atomic number is going to be this number. Like right here for molybdenum, it is 42. So your atomic number is the same number as your protons and your electrons. Then to find your mass number, you're going to take your mass number minus your atomic number, and that's going to give you your number of neutrons. Let's come over here to this. Okay, you've got a lithium atom. Your atomic number is 3. So therefore, if you come down here, you will see that you have 3 protons, okay, that have a positive charge. And then you also have 3 electrons that all have a negative charge. To find my neutrons, then I took 7, which was my mass number. Now the mass number for lithium was actually 6.9. I rounded it up to 7. So it's 7 minus 3, which is the atomic number, equals 4. So now I have 4 neutrons, and they all have a neutral charge, and they're in the nucleus. What's in the nucleus, your protons and your neutrons, make up your mass number, okay? So it's pretty cool the way it all works out, but remember to use the 8-man strategy when you're doing that. Okay, when we come over here, I want us to look at how to count atoms, okay? These are subscripts. They're gonna tell you how many atoms you have. So for sodium, we have 1 atom. We have 1, it wasn't in here, but we're gonna add it. This is what I call adding an imaginary 1. So you're gonna add your imaginary 1, gives you 1 sodium atom. Then you have 4 hydrogen, but then over here, you have a subscript of 2 outside the parentheses. So 4 times 2 is going to give me 8. Okay, so that gives me 8 hydrogen atoms. Then I have my imaginary 1 that I've put next to 0, which is actually oxygen. The O for oxygen times 2 gives me 2. So that gives me a total of 11. Okay? All right. Law of the conservation of mass. Matter is never created or destroyed. It is only changed. And that is a balanced equation. Your reactant goes into what makes your product. Nothing is lost. It's only changed and rearranged. Okay? All right. So coming over here, we have our Country Girls and Guys Love Their Phones, which is actually how we determine whether or not we've seen a chemical reaction. The country stands for color change. Girls or guys stands for gas production. L stands for light production, T is temperature change, and P is precipitate formation. Okay, also we have our mass divided by volume is going to give us density. So if you have a problem on your test that's asking you about density, you're going to use your triangle and you're just going to plug in the numbers that you need. If you've got numbers here, you're going to divide. If you've got numbers here, you're going to multiply. Okay, let's move over. So that takes care of chemistry. Let's move over here to force and motion, because that was our next unit, okay? We have our balanced forces. Remember, balanced force is when you have a net force of 0. So like the other day when we did tug of war, before we even started, That was a net force of 0 on both sides. Also, if the forces down here, after it starts moving, you have what's called an unbalanced force. So right here you see we have a net force of 5 newtons because we have 5 newtons going this direction, 10 newtons going this direction. We're going to subtract, and that's going to give us 5 newtons. Right here, the arrows are going in the same direction, so you're going to have 10 newtons. If the arrows are in the same direction, you're going to add. If the arrows are in opposite directions, you are going to subtract. Determining speed. You're going to use your triangle. Speed equals distance divided by time. So you'll just plug the numbers into your triangle. This should be on your brain dump that you do. It's also on your formula chart, but you'll need to add the triangle to your brain dump. Using the triangles is a great way to solve these problems. Another thing, you need to make sure that if you have a speed problem, you need to use your calculator because you'll know you'll get it right this way. Let's look real quick. I'm going to zoom up here to our Newton's laws. First law is inertia. The law of inertia, an object will remain at rest or in motion unless an unbalanced force acts on it, causing it to move. Then, of course, we have force equals mass times acceleration. Use your triangle, plug in the numbers, and then please use your calculator on these problems. Finally, you have what's called the rocket law, which is action-reaction. An object, for every action force, there's an equal and opposite reaction force. Okay, so that brought us to earth science. So in earth science, the first thing that we started studying about were the plate boundaries. Remember our great little song? Okay. Converging is colliding, diverging is dividing, transform is sliding. We are the plate boundaries. Y'all thought it was a crazy song, but y'all are really doing pretty good with your plate boundaries. So here's a picture of a subduction zone, which is a convergent boundary forming volcanoes. Here's the other convergent boundary that always forms mountains. We have a divergent boundary. The divergent boundary actually usually is in the ocean, forms valleys or mid-ocean ridges, causes seafloor spreading. And then you have your transform boundary, which is actually, this is what causes earthquakes. It's when plates slip side by side. Remember we did the cool graham cracker activity with this? Maybe that'll spark your memory because I think y'all enjoyed doing that one. Okay, then we also, I'm walking over here and I don't need to yet. We've also got topographic maps. A lot of you wanted to know about topographic maps. So I'm just gonna let you really quick look. Okay, remember that these are your contour lines and your contour intervals. The distance between contour lines is your contour intervals. So like right here, we have a contour interval of 25, 50 to 75 to 100. The closer together the lines are, the steeper the slope. The farther apart the lines are, the more gentle the slope. Now, if you look over here, this is the topographic view. This is the profile view of this. So you can see right here, it's gentle, and right here, it's steep. Okay? Hopefully that will help some of you on the topographic maps. I'm going to give you a little hint. A lot of the topographic map questions that you might see, pay close attention to the key. Okay, pay close attention to the key because that is going to actually be the key to answering the question. All right, let's come over here to moon phases because a lot of y'all were asking about the lunar cycle. Okay, so when you've got the lunar cycle, you've got a 27 to 29. STAAR usually says 28 days, okay? But you might see it in between 27 and 29 days. The moon revolves around the earth counterclockwise. okay? When the sun and the earth and the moon are lined up and the moon is between the earth and the sun, you have the new moon. Then from the new moon, you're going to wax with your right hand if you're doing the phases, okay? Like every night, remember I told you, I go out and I look and I do this to see if it's waxing or waning, okay? You're gonna start counterclockwise. The first phase is gonna be a waxing crescent. Then you're gonna have the first quarter. The reason they call it the first quarter, remember the white is still on the right, you're still waxing. It's first quarter because it's 1/4 of the way through the cycle. Then you have the waxing gibbous. Then you have a full moon. Then you're gonna start waning off. You're gonna start waning to the left. That means that your white is going to be on the left-hand side. Then you have a third quarter, and then you have what's called a waning crescent, and then you start all over again. So remember, wax to the right, waning is to the left. Also, let's look at our tides. When the sun, the earth, and the moon are lined up during the full moon and the new moon phases, right here, you have what's called a spring tide. Neap tide is when you have a 90-degree angle between the moon, earth, and sun, and the moon is in its the moon is in its first quarter or its third quarter phase. Okay, you have 2 high tides, 2 low tides every day. So remember when we did our little spring neap, 2 high, 2 low every day. Okay, so maybe that will help you remember the lunar cycle. Okay, finally, remember we started talking about space. Our galaxy is the Milky Way. It is a spiral galaxy. We talked about stars for quite a bit. We talked about the Hertzsprung-Russell diagram. You go up in temperature this direction, and then your luminosity goes up this way. Your blue stars are hotter. Your red stars are cooler. The sun is going to be about right here. This is a main sequence. And your sun is a main sequence, middle-sized, middle-aged star. Okay? Then the next thing that we really focused on was life science. Y'all didn't really ask me a whole lot of questions about life science. Just mainly, you might go through your journal. You might look through the study guide that I gave you about the difference between short-term and long-term environmental changes. Your research was amazing on that. Those have been out in the hall. I think y'all are going to do pretty good on that. Food chains, food webs, y'all might want to review all those on your flashcards. And also body systems. You might review the body systems on your flashcards too. That pretty much covers, I think, everything that we've talked about all year. I trust y'all, and I trust that you are going to do a great job, and I believe that you are going to do pretty good on this test. I think that you're ready. I hope that you will take some time tonight to look over the video again, study your flashcards, do the quizzes if you haven't already, and if you would also look at the study guide that I gave you. And tomorrow, I want you to come in well-fed, eat yourself a good high-protein breakfast. Make sure during the test that you drink a lot of water, get a good night's sleep tonight, and be ready to rock the test tomorrow, because I'm pretty sure that you will. I think you're going to do great. Take your time, do your brain dump, but most of all, I want you to remember that I believe in you and that I love y'all, and I'm going to be praying for y'all. God bless.